All right, good day, everyone. Today, what we're going to be talking about is a continuation of polynomial functions. Okay. Now, the key thing I want you to understand with polynomials is a lot of the stuff that we're going to be talking about. It's kind of like a vocab terms. Okay. In that it's important to know what they are, so that when we actually start to apply them in the grand scheme of things, it's a lot easier to refer to it, to find it, and to actually use it to your advantage. Okay. So a lot of what we do today is going to be strictly based off of understanding polynomials. Okay. Yesterday we talked about the equation. Today we're going to be talking about more about like the graph, things we look for, things we focus on, things that help us determine the difference between one graph to another graph. Okay. So just to quickly review this portion, yesterday we talked about the three main things from the actual equation itself. The three big things that we always come to and look at are the leading coefficient, which is always that first number in any problem, the degree of the polynomial, which is always going to be the highest exponent value within it, and then the constant, which is always going to be our value without some sort of variable connected to it. In this case, there's no x. Okay? Those three things can tell me very specific parts of the graph just by the equation. As we talked about yesterday, something like the constant can just tell me what the y-intercept of the graph is. Okay, that's a very important idea if you can just look at something and find the y-intercept based off of it. The degree tells you the maximum number of x-intercepts on the graph that you can have. So you could cross the graph 5 times, and that's all based on the degree. Okay? So these things are going to be important for the grand scheme of things. However, we also need to talk about some other small things within a graph itself that are going to be important. Okay? For example, the first thing we want to talk about is this idea of a relative min and a max. Okay? So the idea of a relative min and max is the fact that, not relative. The idea of a relative min and max is that it's really just applying this idea of what is the largest maximum minimum values that we could truly have within this problem. So when I look at a graph, truthfully, there's nothing different between looking at a min and a max when I'm trying to find my relative min and max. Okay? That's one of the key things I want you to understand, at least to this point. So if I look at a graph, a relative min is going to be my lowest point, but it's not necessarily where this line goes right here. Okay? It's the lowest value where I change directions, or in other words, if you want the easy way to remember it, it's where you have a bump. Well, in that case, my relative min is actually sitting right here. Notice how it's my first coordinate where I change direction, and I'm going from a decrease to an increase, creating that minimum or bottom bump value. So I have a relative min at 0, 2. With that being said, my relative max is then in the other direction, or that other change of direction, which is this top bump up here. Okay? Now this one's a little bit more challenging. We can just go ahead and guesstimate that one. We'll say about 0.5 or 1/2. And we'll say it gets up to about, it looks like it's going up by 2.5s. So we'll say that's about 12.5. Okay? So that's our relative min and max, things that we focus on within the graph that kind of helps us differentiate one from another. Okay? So that's going to be the first thing we focus on within an actual polynomial, is that how can we find the relative min and max, and how can we use that to our advantage? The second thing we're going to focus on is something called end behavior. Okay? Now, end behavior kind of describes exactly what it is. Okay? It's going to describe how the graph reacts at the ends of each of your graph. Okay? How I always look at the word end is try to think of arrows. Where is your graph pointing? Okay, at end behavior, you're really trying to figure out where does this graph point at the end of it. Okay. However, you have to understand that a polynomial is basically a continuous line, right? In that it's not just one single arrow pointing in a single direction. You have an arrow down and an arrow going up. So what end behavior needs to do is it needs to describe both of these values. But how do we do that within a function? Well, pretty straightforward. Okay. End behavior has a bunch of notations built into it. some dealing with x and some dealing with y. How they look is similar to this. X arrow infinity means right. X arrow negative infinity means left. And the simple idea is, if you think about the x-axis, if I were to split this in half down the middle, you would have a left side, which is all negative, and a right side, which is all positive, correct? Left is negative, right is positive. Well, those two values directly relate back to your actual negative and positive infinity signs. So what we're really referencing is not necessarily like negative infinity, not to try to make it more complex, not to make it more complex, but really what we're referencing here is the left and the right side of the graph. Notice how this kind of allows me to look at two different parts. We have this part and we have this part, each on a singular side. But at the same time, we also need to figure out our y values. Now, y is almost written the same way. However, it just stands for two different ideas. Y to positive infinity is going to stand for up. Y to negative infinity is going to stand for down. And the simple idea is that it's kind of the same idea of, if I split this graph in half here, up would be positive, down would be in the negative, right? Because that's how y values work. So really all I'm doing is trying to find these coordinates and describe how they look using my mathematical notation here, okay? So now if I clean this graph off and I try to state the end behavior of it, all I want to do is focus on what's really being described here for me, okay? Well, let's go ahead and take a peek at this and actually try to come up with this. So the first graph or first line we're going to look at is right here, this arrow, okay? And the thing you want to understand is really you just have to get two different descriptions. You need one of these two values and you need one of these two values here. You need both an x and a y. So really, when I look at this graph, I want to say first and foremost, am I on the right or the left-hand side? Well, if I think about this graph, this is the right-hand side of the problem. So for my end behavior, it's x is going to the right of the problem. A little choppy here. Let me clean this up. X arrow positive infinity. That's telling me I'm looking at the right-hand side of this graph. Now, your y coordinate, it's where it becomes really important. Your y coordinate tells you what the line is actually doing. Now, this line obviously is doing a lot of different things. It's kind of going like almost northeast, if you want to call it that, how it's kind of gradually building off to the right there. But really, we can break this down into two different things, up or down. Well, in this case, if I look at it, this line is pointing up. So really, to finish off my end behavior, I just want to state that when I look to the right, the line points up. So you see how I used my mathematical notation to describe that? X arrow infinity meant right, y arrow infinity meant down. Well, now, since I've done the right-hand side, I also have to do the left-hand side because there's two different arrows on the graph. So now I got to write x arrow to negative infinity, which means left. And I have to state what the arrow is doing. Well, on the left-hand side, the arrow is going down. Okay? And that's using our end behavior to our advantage. Now, when we mix this all together, we're going to start looking at graphs and be able to pull all this information out. Okay, pretty soon, we're going to be able to look at a graph similar to these right here, and we're going to be basically able to say like all these different important things about it. For example, if I look at the x squared graph, I could plug it in the calculator and get this picture here. And I could tell you it has a degree of 2, which I can sit here and tell you that's going to mean multiple things. It's going to tell us odd and even eventually. It tells us I could have a possible of 2 intercepts, everything like that. My leading coefficient is positive, which makes it point up. I don't have a constant, so there's no y-intercept. And then even my end behavior is x to the right, y is going up, and x to the left, y is going up. So notice how by just taking that little bits and pieces of the graph, by looking at both the equation and just kind of the sketched picture I drew there, I can pull out all that information. Now, really at this point, our goal is to just get that information down. Later on, we're actually going to use it to our advantage slowly but surely to actually figure out certain ideas, okay? But number one, the thing we have to be able to do is come up with them, understand them, and use them, okay? So answer any questions around the Ed puzzle. Make sure you finish watching the thing completely, and I will see you tomorrow in class. Have a great day.